Alright, here's our second video, part 2 on measures of variation. Again, we're focusing on range, interquartile range, and outliers in data sets. This data set here, you'll recall we talked about yesterday, and it is not a data set that really seems to feature an outlier. You can see even though there's a couple of ages that are a little bit higher than the others, they're all still fairly close when it all comes down, because this data is pretty spread out. So you'll recall a measure of center is a single number that kind of represents an entire data set by where the data cluster. Where a measure of variation, which we've learned two of, is a measure that lets you know with a single digit or a single number how far spread out the data is. So we're going to be focusing on range and interquartile range again today. And we're going to take a look at this data set. If you'll recall, these are made up ages of teachers at Hamilton Middle School, but I will tell you one age is true. And that age is my age, is listed there. So when I mention in my Google form which age is true, which is my age, which is 44, you're going to know that answer for your Google form, but you wouldn't know that just by looking at the pictures. And that was intentional because I know there are several students that have been fast forwarding through the video. It's been bothering me a little bit, so I'm hoping that you guys are watching the videos straight through. So with this data we talked about yesterday, in order to find the range, we subtract the highest number and the lowest number. So in this case we call that the lower extreme and the upper extreme. So if I wanted to find the range of this data set, I would simply subtract that upper extreme and that lower extreme. So the upper extreme is 62. The lower extreme is 24. And although many of you could do that in your head, it's perfectly fine to use a calculator for this part. So 62 minus 24 gives me a range of 38. So the range of this data is 38, which tells me this data is pretty spread out. Now, the second focus and the main focus of today's objective is to learn about interquartile range. And in order to find the interquartile range, you need to split the data up. So the first thing we're going to do is we're going to split the data in half. And you can see right here that indicates that there are 6 numbers to the left of center and 6 numbers to the right. And I'm also going to mark this on my raw data down here between the numbers 37 and 38. This gives me my median. Okay, and just so you know, median is actually quartile 2 because it splits the data right in half. So in this case, my median is the difference. If I add up 34 and 38 and then divide by 2, I get a median of 36. So instead of putting an M for median, because you'll recall that we have mean, median, and mode, they're all measures of center, I'm going to actually write the word, and I'm also going to label it with an uppercase Q with a subscript 2, because the median is actually quartile 2. Then I'm going to note that I'm going to split the lower half of my data in half as well. And that's going to give me kind of a separation right there in between the two 28s. What that is the middle of the front half of the data, or the lower half of the data. And that number right there, that 28, because 28 plus 28 divided by 2 would obviously equal 28, that's what we refer to as quartile 1. Okay, or the lower quartile. So now we're going to do the same thing with the upper half of my data. I'm going to split it into 2 parts. And now you can very clearly see why they're split into quartiles. You know, you've got quartile 1, quartile 2, quartile 3. They separate that group. All right? And so what we're going to do now is we're going to simply going to identify that quartile 3 would be, if you add up 44 and 48 and divide by 2, you get 46. So that's like the median of the upper half of my data, and that would be quartile 3. While we're here, since we already identified this as my upper extreme and this as my lower extreme, I think it's worth noting that those 5 numbers are called the 5-number summary. And what's cool about the 5-number summary is it helps you to identify your median, your interquartile range, and your range. And it tells you a lot about a data set. It tells you where the center of the data is, and it tells you how spread out it is, both the entire data spread out as well as the center of the data. I will say this concept is one of the more challenging concepts for 6th grade, but analyzing data is a really important goal for 6th grade. And we want to make sure that we can come up with measures of both center and variation. So let's see what the book has to share with us on data. And I'm going to zoom this in so you can see a little bit better. This is actually the information that we shared yesterday a little bit of. Okay, so the quartiles, there we go. The quartiles of a data set divide the data into 4 equal parts. Recall that the median, second quartile, divides the data into 2 halves. So the median of the lower half of the first quartile is quartile 1, and the median of the upper half of the third quartile the median of the upper half of the data is your third quartile. You'll note this data set had an odd number, so had an even number, just like before. But the lower half of the data had only 5 numbers, so my quartile 1 was part of the data, and my upper half also had 5 numbers. Remember, when you split the data in half, both the lower half and the upper half should both have the same number of items. Now, interquartile range is the difference between the third quartile and the first quartile. So the IQR basically represents the range of the middle of the data. So you see how they kind of grade this out. This is the middle of the data, and you can see that data is pretty close in the middle there. Okay? And that's what we expect. Typically, your data cluster is in the middle. So here's a kind of a word problem that they created. Shows the top speeds of 12 sports cars. Okay, and when you look, you can see the highest. We're definitely interested in that, and then the lowest. Okay, first, after we put them in order, we can immediately find where the middle of our data is, and then we can find the middle of the lower half of the data, which is clearly 235, and the middle of the upper half of the data, which is 255. We subtract those 2 terms, and that's how we find our interquartile range. All right, so now we're going to do some actual examples. To find the interquartile range, we know we have to put the numbers in order. Now, we talked in class about the importance, or in our video yesterday, the importance of not needing to put the numbers in order to find range, because, it's pretty obvious. But because we're going to need to find both, I'm just going to go ahead and put all this data in order. And it looks to me, they conveniently put it in order, but they didn't put it in a straight line. So I'm going to rewrite it in a straight line to make it really easy to work with. So 21, 53, 74, 82, 84, 93, 103, 108, 116, 122, 193. I always like, when I'm done doing things like this, I count them up, make sure I have them all. So I've got 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now that I know that I've got 11 numbers, it's an odd number, I know the median is going to be part of my data. So that should be my 6th number. Let me check. 1, 2, 3, 4, 5, 6. I think this is my median. And I can check that by counting the numbers to the right. There are 5 of them. And the numbers to the left. There are 5 of them. This is a great strategy for making sure that we identify the correct terms. So now that I've done that, I'm going to go ahead and find the middle of the lower half of the data. That's right here. And the middle of the upper half of the data. And that's right here. So this is quartile 1, and this is quartile 3. Now, I've done all that work. I can go ahead and find the range and the interquartile range. To find the range, I'm going to subtract my upper extreme, 193, minus my lower extreme, which is 21. Notice I didn't circle them or move them before I tried to organize my data, because if I took those away, that would alter my answer. So I'm going to go ahead and use that calculator again, and I'm going to go ahead and subtract 193 minus 21, and I've got a range of 172. And then I'm going to go ahead and subtract my quartile 3 minus quartile 1. That would be 116 minus 74. And I get 42. So my IQR is 42. So you can see that as much as it can be a little confusing, it's not difficult. If you can follow the steps of putting the numbers in order, identifying the middle of the data, and then finding the middle of each half of the data, it's pretty easy to spot. Now, keep in mind that with both range and interquartile range, we're measuring a distance, and that's why we're subtracting and not dividing. That's a very common mistake people make, so we want to make sure that we're measuring a distance. All right, now here's our final question, which actually is going to summarize both our measures of center as well as the measures of variation that we've discussed. So here's our question. We want to know, compare these students' test scores. And so what we're going to do is we're going to do each student individually, and then when we're done, we'll compare all their measures of center and measures of variation that we've done. So I'm going to zoom in so we can see a little bit better of, oh no, I'm going to zoom out. We're going to go ahead and do one student at a time. We're going to start with student 1. These numbers are not in order, so the first thing I want to do is put these numbers in order from least to greatest. I'm going to get 60, 82, 89, 91, 94, and 100. All right, so now I've got those numbers in order. I want to find out the mode. Oh, there's no number that occurs more than any, so I'm going to write no mode. So that's not statistically interesting to us. Now, finding the median is very easy. Right down the middle there, I've got an 89 and a 91. I can go ahead and add 89 plus 91 and then divide by 2. And that gives me a median of 90. My mean, remember we refer to the mean because our teacher's mean for making us do all that work. A lot of adding that goes on here. It's a lot of steps. So 60 plus 82 plus 89 plus 91 plus 94 plus 100. And we get 516 as our total. We'll divide that by 6 because there were 6 tests. And this student's got a mean score of 86. Now let's go ahead and find our range. We're going to subtract 100 minus 60. Most of you know that that's 40. And then finally, to find our IQR, we need to find the middle of the lower half of the data, which is 82, and the middle of our upper half of the data, which is 94. So I'm going to subtract 94 minus 82, and that gives me an IQR of 12. So we've completed the work for student 1. Now we're going to go ahead and do the same thing with student 2. Again, we're going to place these numbers in order from least to greatest. 72, 78, 82, 84, 100, and 100. So the student does have a mode of 100, so it is statistically relevant that they've got one grade that happened more often than any other. However, just based on looking at the raw data, you can see the student didn't only get 100s on their scores. So we're going to go ahead and look at the other measures of center and variation. So again, I like to kind of start with that median since my numbers are right in the middle here. I've got 82 and 84. Now you could use a calculator for that, but to me it's very obvious that 83 comes right between there. So I'm going to save some time and be efficient. Let's go ahead and find our mean, okay? And we're going to do that again by adding up all the numbers and dividing by 6. So 72 plus 78 plus 82 plus 84 plus 100 plus 100 equals 516. And we're going to divide that by 6. And we're going to find out this student also had an average score of 86. And I think that this is going to be why we're doing this example. We're realizing that these numbers are very different, but the average still ended up being the same. The mean ended up being the same. So let's go back and do the range here. We would subtract 100 minus 72. And again, we can do that on our calculator. 100 minus 72. That gives us 28. And then we're going to do the IQR. And remember, we're going to find the middle of the lower half of the data, which is 78. The middle of the upper half of the data, which is 100. We'll do 100 minus 78. And we get 22. And so you can see right here that student 1 their data was much more spread out, but the center of their data was way closer together. So this guy, or this student, the data was not spread out as much, but the IQR was spread out. So their range, their data was kind of all over the place, where this student was pretty consistent. They just had kind of one low score. And so what we're going to notice is that all of these measures help us to identify. And if I was to compare, even though this student got 2 100s on their grade, I would say student number 1 is more consistent with their work and generally does better, because note their median is higher, okay? And their interquartile ranger is a little more clustered. That indicates that really it was just this one score which turned out to be an outlier for them, and that's why their grade was lower. Otherwise, they would have done much better. Okay, so I'm glad you guys stuck around till the end. Like I said before, interquartile range is one of the more challenging activities because it requires so many steps, but it will be necessary as we move forward to box and whisker graphs in Chapter 10. So I do hope that you master this lesson. Good job.